We're going to start off our discussion today with derived units because density is a derived unit. Derived units are units of measurement that are derived, usually with a math equation, from the other 7 SI base units. So here's an example: area. The definition of area is length times width, length times length, or length times width. Length is measured in meters. Length is measured in meters. You multiply the two together, you get meters squared. Volume, length times width times height. Measure all three of those quantities in meters and you end up with meters cubed. Speed, the amount of distance traveled per unit time. The SI units for distance are meters. The units for time are seconds. You take a unit of measurement that's in meters and you divide it by seconds, you get meters per second. So a derived unit is derived from a mathematical equation in which other SI base units are combined in some way. Density is a derived unit. It's actually a ratio of the mass to the volume of a substance, the SI units of which are kilograms per meters cubed, but we're going to be using other more commonly expressed units such as grams per centimeter cubed. I think of density as how compact an object is. I have two objects here, particulate level diagrams, to show you the differences in density between a loosely packed and a very tightly packed object. Low density objects have their particles very spread out. The particles have space in between them. The packing is very loose. High density particles are packed more together. Like when you make a good snowball, you take the snow and you pack it together in a very tight space. This table summarizes some of the densities of various objects. Air, not very dense. Gold, one of the highest density elements on the periodic table. In a mixture of water, wood, ice, which would you expect to rise to the top? I'll give you a minute to look at this table and figure that out. Ice and wood are less dense than water, so the water would probably be on the bottom, followed by the ice, and then the wood's probably going to float on top of that. The lower the density, the more it's going to float compared to things that are denser. Here's a good conceptual question. If you have the same mass of lead, gold, and aluminum, which one will have the highest volume? Take a moment, and I want you to think about that, and we'll go over the answer. All three of these metals are at the bottom of the table. If I have exactly the same number of particles of aluminum as I do lead and gold, gold particles are actually packed together the most, right? Because they are the densest. Aluminum has the lowest density, which means its particles are going to be the most spread out. So if I have the same mass, same number of particles, aluminums would have the highest volume because it would be the most spread out. Anytime that we're working with density problems, I'm going to show you a series of steps that I use to keep my work very organized. We have an emerald and we're given the mass, we're given the density, and we're trying to figure out what its volume is. First thing I always do is I write a list of all of my givens. My density is 4.02 grams per centimeter cubed. I'm putting my units in with my variables. I'm declaring my variables. My mass is 17,230 grams, and my volume, I don't know. Second step is I write the equation that I want to use to solve this particular problem, which is density equals mass divided by volume. Now, if I'm solving for volume, the volume of an object is actually equal to the mass divided by its density. How did I get to this math equation from here? Well, if I take both sides and multiply them by volume, then divide by both sides by mass, I get this equation over here. Substitute your values in. I'm substituting my values in for what I know to find what I don't know. My mass is 17,230 grams. Notice how I put the units in there to show you that if I have grams divided by grams, those units are going to divide out and give me 1, which leaves me with divided by 1 over centimeters cubed, which mathematically will give me centimeters cubed by the end of that calculation. I'm going to perform this math operation. 17,230 divided by 4.02. And if I round to the correct number of significant figures, 4,290. 3 sig figs. I started with 3 significant figures. And that's my answer, with a unit, centimeters cubed. It's helpful to put those units into your work to remind yourself that your final answer must have a unit. I'm going to give you a few minutes to work these problems out. This is the point in this video that I would encourage you to just pause, work through these problems. The answers are below, and then we're going to go over these questions that you might have about density in class.